In the following video, let's go ahead and take a look at the integral of 1 over the square root of x squared plus 1 dx. So there's a special method for solving this. It's a trigonometric substitution. What we're going to use is tangent. So let's go ahead and draw a triangle out. We have a right triangle with some theta. Theta is right here. And we have, for the hypotenuse, x squared plus 1. Over here we have x, and over here we have 1. So the reason this here is the square root of x squared plus 1 is because a squared plus b squared equals x squared. So x equals the square root of a squared plus b squared. I should probably call that c. Let's go change that to c. C squared. So c equals that. So that's where we got this here. And the reason we did that is because of this down here. So what can we get from this? We can say that tan theta is equal to x over 1, or just x. So then x equals tan theta. And then dx equals secant squared theta d theta. Let's hold on to these because we're going to be substituting these in for x and dx. So the integral becomes secant squared theta d theta over the square root of x squared. So x is equal to tan theta, so we get tan squared theta plus 1. And the reason this is advantageous is because down here we have a trigonometric identity. Tan squared theta plus 1 is equal to secant squared theta. And the reason this is the case is because cosine squared theta plus sine squared theta equals 1. And if we divide by cosine squared on both sides, on the left-hand side, we get 1 plus tan squared theta is equal to secant squared theta. So that's how we got that identity. So we can now rewrite this as the integral of secant squared theta d theta over the square root of secant squared. So that equals the integral of secant squared theta d theta over secant theta. We notice that one of the secants cancels, so we're left with the integral of secant theta d theta. And this is one that you kind of just have to memorize. The integral of this is natural log of tan theta plus secant theta. And then don't forget the arbitrary constant plus c. And what we want to do is we want to transfer back into the into x. So we said that x is equal to tan theta. So this equals natural log of x plus, and then secant theta we can derive from this triangle. So we know that cosine theta equals 1 over the square root of x squared plus 1. And secant theta equals 1 over cosine theta. So secant theta equals the square root of x squared plus 1. So we get square root of x squared plus 1 here, and then plus c, and that concludes the integration of 1 over the square root of 1 plus x squared dx. Awesome.